Today we're going to talk about section 4.1, and it's on graphing quadratic functions in standard form. So this is going to take us back to our quadratic algebra days, so the year before you took geometry. And our goal today is simply to graph some of these quadratic functions. Now, a quadratic function is a function that can be written in the standard form, y equals ax squared plus bx plus c. That formula should be on your note card. And this is where a is not going to be equal to 0. Now, if we look at quadratic form, we know that the shape is going to be a parabola. And that's a graph of the quadratic function. Now, a parabola is simply a U-shaped curve. Okay, so it's going to open up, could open down, but it will make a U. The vertex is going to be the highest or the lowest point of that parabola. Now, obviously, if our vertex opens up, then our vertex is going to be the lowest point. So in this case, our vertex would be right there. If our vertex opens down, then our vertex will be our highest point. We're also going to talk about something called the axis of symmetry, and that's a line that divides the parabola into mirror images and passes through the vertex. So each side of the vertex is going to be identical to the other. It's going to look very similar to the absolute value functions we graphed, except for this is going to be a curve rather than two straight lines on each side. Now, the parent function for all quadratic functions is simply the equation f of x equals x squared, or y equals x squared. So if we'd make some ordered pairs, we put in our numbers, we're going to get a parabola that looks like this. The vertex is here at 0, 0. Put in 0, you get 0. Put in 1. 1 squared is 1, you'd get 1. Put in 2, you'd get 4. If we'd put in 3 for the x squared, we'd get 3 squared is 9, so we'd have an ordered pair of 3, 9. It would continue on. Okay. The axis of symmetry, in this case, goes through the vertex, and it's x equals 0, because that is the vertical line that goes through the vertex. So the axis of symmetry and the x-coordinate will always be the same. So what we're going to do now is we're going to graph a couple quadratic functions, and we're going to do so again by making a table of values, just like we always do. First time we start looking at graphing, we're going to make a table of values. So I'm going to put in 0, 1, 2, -1, -2. Doesn't matter what numbers you put in, but if we're going to put them in for x, put in 0, we get 0. 0 squared is 0 times a half, so this is 0. Put in 1, 1 squared is 1, so you're going to get a half. Put in 2, 2 squared is 4, 4 times a half is 2. And we're going to get the same thing if we put in -1. -1 squared is 1, 1 times a half. So we have these points. 0, 0, 1 a half, 2, 1, or 2, 2, -1 a half, -2, 2. And there's our graph, and again, we're going to make sure to label the vertex. Now, I'm also going to put my parent function on here because it says we want to compare the graph with the parent function. So, vertex and the points here. So, the red one's my parent function. The blue one is the function that we graphed. So now, what we want to do is compare the graph of y equals x squared, our parent function, to the blue graph. And if we'll notice, they both have the same axis of symmetry, which is x equals 0. They have the same vertex. The only difference between these two graphs is that the graph that we drew, y equals 1/2 x squared, has a graph that is wider than the parent function. So we're going to say that the graph is wider than the parent function and has the same axis of symmetry and vertex. All right, so let's go to the second one. It says graph function of the form y equals ax squared plus c. So now we notice we're going to have a number at the end, and we're going to see what does that do to our parent function. So if we start by, let's just throw the parent function up on our graph. Just so we can compare that. And let's make a table of values. So let's graph the other one. And again, let's just start with the numbers 0, 1, 2, -1, and -2, just so we're in the middle of the graph somewhere. If we put in 0, again, we're putting it in for x right there. So 0 squared is 0 times -2 is 0. 0 plus 4 is 4. Put in 1. That's going to give me -2 plus 4, which is 2. If we put in 2, that's going to give us 4. -8 plus 4 is -4. Put in -1. That's going to give us 1 times -2 is -2 plus 4 is 2. And if we put in -2, that's going to give us 4 times -2, which is -8 plus 4 is -4. And so let's graph these. So we get 0, 4, 1, 2, 2, -4, -1, 2, and -2, 4, -4. And so if we graph this one, the vertex is up here at 0, 4. And has an axis of symmetry at x equals 0 still. So now, again, if we compare this with the parent function, what do we notice? Well, the graphs have the same axis of symmetry. And that's x equals 0 for both of them. But now, if we look, our function has a vertex of 0, 4. And what do you notice about how wide it is? Okay. This one's going to be skinnier or narrower than the parent function. Okay. So when we look at these graphs, notice here, when there was nothing behind it, the vertex was the same. It was at 0, 0. When we put the number +4 behind our vertex, what happened to it? Our vertex now became 0, 4. So this is really just a vertical shift. Okay? We're shifting that graph up. And notice, again, when this one was a negative number out front, what happened to our parabola? It opened down. So it's a reflection. And then that number again was bigger than 1, the absolute value of bigger than 1, which means it's a narrower graph. So when we look at graphing all of these in general, that's going to tell us something. Let's do questions 1 and 3. So go ahead and try questions 1 and 3 on the guided practice, and then hit play when you are ready. So if we look at the graphs for number 1, this one is a reflection of our parent function. It opens down and it is narrower. It has the same axis of symmetry, which is x equals 0, and the same vertex, which is 0, 0. Number 3, if we compare that one to the parent function, it now has a vertex of 0, 2 that have the same axis of symmetry, which is x equals 0. And so this one is wider than our parent function, and it was shifted up 2 units. So if we want to look, well, so far we looked at graphing these quadratic equations by making a table of values. We're going to look at all of the general properties of these quadratic functions if they're in standard form, and look at how we can graph all of these, because as we've done so far, all the axes of symmetries were on x equals 0. Which is great when we're plugging in ordered pairs, but it's not always going to be the case, so we're not always going to be able to use the points 0, -1, 1, -2, 2, and things like that. So if we look at the properties of y equals ax squared plus bx plus c, in the first side here it says we're going to look at the graphs y equals ax squared plus bx plus c if a is greater than 0. Well, what that tells us is this. If we have a greater than 0, which means it's positive, we know that our parabola is going to look like this. It's going to open up. On the other side, if we have one that's negative, it means our parabola is going to open down. So the bullets here say if a is positive, the graph opens up. If a is negative, it opens down. Again, just like we talked about before, if the absolute value is greater than 1, if that number is greater than 1, that the leading coefficient, then it's going to be a narrower graph because it's going to go up more quickly. If the leading coefficient is less than 1, if it's a fraction, that means the graph is going to be wider. The axis of symmetry is x equals -b over 2a. This is probably the most important piece of information that you need out of this section, that needs to make sure that it gets on your note card. X equals -b over 2a. That is how you find the axis of symmetry of any quadratic function in standard form. And that's also going to be the x-coordinate of the vertex. And then we also know that the y-intercept is c. So the point 0, c is one of the points on the parabola, which makes sense because you put in 0, the other things cancel out, and you just have c left. So in example 3, we're going to graph this function. All right, so the first thing that you're always going to want to do is take that. Find the vertex, x equals -b over 2a. Well, remember here, a, b, and c, we want to find what they are. Well, in this case, a is -1, b is 6, c is -8. And so we're going to take -b over 2a, so it's going to be -6 over 2 times -8. Which means x is going to be -6 over -16. And if we reduce that, we get negative, well, there's going to be positive, so it's going to be 3x. Oops, put it in the wrong number. A, that should be a. Let's try that again. So 2a, and a is negative 1, so it's going to be negative 6 over negative 2, which is 3. Right, because b is 6, a is negative 1, and so we're going to go 2 times negative 1 in the denominator, so x is 3. Now the reason we want to do that is because we're going to now make our table of values, but we know that our vertex is going to be 3 something. So that's my axis of symmetry. As soon as you find that, you can draw your axis of symmetry, x equals 3. That's going to be the line that splits our parabola in half. So if that's the axis of symmetry, my vertex must be on there somewhere. So let's put in 3, see what we get. So if we put in 3, we're going to get 3 squared is negative 9, 6 times 3 is 18, minus 8. So we have 9 minus 8, which is 1. So the vertex is going to be 3, 1. Okay, we know that this parabola is going to open down because it's negative. So I'm going to write my vertex up here above it so it's out of the way. Okay. So now that we have the vertex, we want 2 points on the right and 2 points on the left. So I'm going to put the x values on the right, 4 and 5, and the y value or the x values on the left, which are 2 and 1. Now the numbers for 4 and 2 should be the same, and the numbers for 5 and 1 should be the same because they're the same distance from the axis of symmetry. So if we put in 4, that's going to give us negative 16 plus 24 minus 8, which is going to give us 0. So 4, 0 is one of my points. Now I'm going to put in 5. That's going to give us negative 25 plus 30 minus 8. That's going to give us negative 3. The other side should be symmetrical. So let's plug those in just to make sure. So if we do that, we're going to get negative 4 plus 12 minus 8. So that's going to give us 0. So that one was good. And we're going to put in 1. It's going to give us negative 1 plus 6 minus 8. And that gives us negative 3. Try that again. And there's our graph. Symmetrical about the axis of symmetry, which is x equals 3, and the vertex is the ordered pair 3, 1. So let's go ahead and try to graph one of these. And let's just do number 4. So go ahead and try to graph those. You can hit pause on the video, hit play when you are ready. So if we graph this, we get the vertex of 1, negative 2, which goes through the axis of symmetry, which is x equals 1. So the next thing we're going to talk about is the minimum value. And the minimum value is the y-coordinate of the vertex when the parabola opens up. And so if we have a parabola opening up, and here is our vertex, xy, the vertex is the y value. X tells you how far you go left or right, y tells you how far you go up or down, so the vertex is the y coordinate of the vertex. So the minimum value is the y value when the graph opens up. The maximum value is the y coordinate of the vertex when the parabola opens down. Again, here's our vertex. We'd have the ordered pair xy. In this case, the maximum value would be the y coordinate of the vertex because it opens down. The y value is the highest number that you would get. So in example 4, it says find the minimum or maximum value. Tell whether the function y equals negative 2x squared plus 4x plus 3 has a minimum value or a maximum value. Then find the minimum or the maximum value. Well, you should be able to tell us instantly whether this has a max or a min. Okay? Well, what do you know about this? This negative number here tells us that it opens which way? Down. So if it opens down, it has to have a maximum value. Okay, so it has to have a maximum value. So what do we need to do? Well, we know that the maximum value occurs at the vertex. So we need to find the vertex. So let's find it. X equals negative b over 2a will give us the axis of symmetry, which is also the x value of the vertex. So let's plug those in. A is negative 2, b is 4, c is 3. So let's plug these numbers in. So we're going to have negative 4 over 2 times negative 2. So this is negative 4 over negative 4, which is 1. So the vertex is going to be 1 something. Well, now we need to plug that into our original equation to find the x value. So that's going to give us negative 2 plus 4 plus 3. So our vertex is 1, 5, which makes 5 our maximum value. The same thing would be true if we're looking for the minimum. Okay, the minimum value, if we're looking for a minimum value, we would find the vertex and the y value just like we did here, only in that case we would know that the parabola opens up. So now let's look at a word problem. In example 5, it says a video store sells about 150 DVDs a week at a price of $20. The owner estimates that for each $1 decrease in price, that about 25 more DVDs will be sold each week. How can the owner maximize his weekly revenue? So when we look at an equation like this, we know that our revenue, we'll call it R of X, and you call it Y, you call it whatever you want, your profit. But we know that the price times how many they sell is going to equal how much you make. So in this case, he has 150 and he sells them for 20 bucks. All right, now it says here that the owner estimates for every dollar decrease in price. So if he takes his price and decreases it by $1, that's going to take his number of DVDs, which is 150, and increase it by 25. So here's our function. Now this is not in the same form as the ones we had before, so what we're going to do is we're going to have to make sure to put it in that form. So remember back to the days, we're going to do some foiling. We're going to multiply the firsts, the outsides, the insides, and then the lasts. All right, so that's what we're going to be looking at here is we're going to do a foiling problem. So R of X is going to equal, first will give us 3,000, outsides is 500x, the insides give us negative 150x, and the last one's negative 25x squared. So if we rewrite this in standard form, negative 25x squared plus 350x plus 3,000. So now we have this in standard form. A is negative 25, B is 350, and C is 3,000. So from here, what we want to do is we want to look at maximizing his weekly revenue. So we know that this parabola is going to open down. Again, they ask us for the maximum, so we have to find the vertex. So if we find the vertex, we're always going to start with the axis of symmetry. So it's going to be negative 350 over 2 times negative 25, which is negative 350 over negative 50, which gives us 7. So the vertex of this parabola is going to be 7 something. So if we plug that in, if we plug in 7 to our original problem, well, and let's plug it in right here since we already did the work on that part of it. So let's plug in 7. So we're going to have negative 25 times 7 squared plus 350 times 7 plus 3,000. So this is going to give us negative 1,225 plus 2,450 plus 3,000, which gives us a total of 4,225. So that is the y value of our vertex. Okay, we know that the maximum profit he's going to make is going to be this because that's the y coordinate of our vertex. Now we need to make sure we answer the question. It says, how can the owner maximize the weekly revenue? Well, we know that the 4,225 is the maximum they can make, so how can he do that? Well, we look at this problem, and what does x represent? And that is, in this case, x represents the reduced price of the CD by $7. So if he takes $7 off of the price, that is where he's going to get his maximum profit. So we would need to write that. He needs to reduce the price by $7 to maximize his profit at 4,225 bucks. Your homework assignment is listed there. Now remember, of all of the stuff that we talked about, we want to make sure that you can graph these quadratic functions. And if we go back to the equation in standard form, you must make sure that you know what the quadratic equation is in standard form. So y equals ax squared plus bx plus c. And the axis of symmetry is x equals negative b over 2a. So make sure that you know how to graph and how to find the axis of symmetry. And that axis of symmetry will be where the vertex must be on that axis of symmetry. And then remember, the maximum and the minimum values are the y coordinates of the vertex. So there is your assignment for section 4.1.